So my name is Amit. This is Jeremiah with me. I'm from McAfee. Jeremiah's from VMware. Let me introduce myself first. I'm Amit. I lead the product management for cloud workload security, focusing on VMware, VMware NSX, OpenStack, AWS, Azure. So by show of hands, how many McAfee customers? Cool, that's great. How many of you involved with security? Oh, that's great. How many of you are going into cloud or thinking about going to cloud, already in cloud? Great. AWS? Cool. Azure? Any other cloud that I missed? GCP? Cool. All right, before we start, I'm going to let Jeremiah go ahead and introduce yourself.
Sure. I'm Jeremiah Cornelius, and I'm the security architect in the Global Strategic Alliances organization at VMware. Big part of what I do is help security partners like McAfee work with us on taking their controls, building new use cases that are relevant to the platforms that VMware puts out. In particular, the target that we've been working towards over the past several years is how to integrate security deeply into the fabric of the software-defined data center. That principally means how do you tie it to NSX, and that's a big part of what we're going to be talking about today. Amit did a little show of hands, I know, around some of the kinds of deployments that you either had today or were looking forward. How many of the people here right now have NSX either deployed or at least in some kind of proof of concept lab right now? Okay, good. This is amazing, again, because a year ago I would get maybe one hand in a much larger group. So this is good. I think between the two of us, we've been driving towards this for...
Yeah, we have been doing this...
4 or 5 years.
Yes, yeah.
So to get to this point is great. I think we have the right messaging then and the right connection for this audience, which is great. I don't know whether we need to go tremendously over the disclaimer because you've probably already seen this for about 3 days, but they require us to show it, so there we are. We got an agenda here. We're going to talk about NSX at the heart of the cloud vision so why we are doing the software-defined data center, why we're making the investments that we are there, the promise that we are looking to fulfill with that in terms of being able to create an extension of the existing operations and management experience and security operations into all of these various different types of environments that we were talking about up front and asking you. So again, very clearly, raw AWS, go into Azure, onto different private and hybrid clouds with underlying VMware technologies. In particular, the showcase item right now, has been the VMC, putting the VMware SDDC on Amazon Web Services, and so we use that as an illustration for a lot of that. It's an ongoing evolutionary approach that we're going to have to doing this. So I'm using that as an example. Questions about that, and how things will be implemented at what stages are probably left better for the Amazon sessions. We touch on that. Then we talk about threat defense. I really am going to transition then after talking about how we control for and how we use the SDDC to offer better security than the physical world, and how we work with McAfee to integrate at the network level. Then Amit will talk about threat defense and then on into what they've done to implement cloud security, both on NSX and continuously across the various types of environments for different types of workloads. Everything, not just server-based application computing, but containers, IoT, all of the sorts of deployment and protection targets that are rapidly changing how we have to think about security and, importantly, the scales that we're doing this at. You can talk about your disclaimer here.
It's again the same with two different organizations. Obviously, we have different disclaimer, but I'm pretty sure you're familiar with this.
So this is really why VMware is doing this. The cloud and the hybrid cloud, not just opportunity, the push into it is tremendous. Customers at this point, that the numbers are showing, this is where the investment has to be. $236 billion is the market just in projected about the next 18, 24 months. The projected growth for just the infrastructure cloud market alone there. And of course then the number of organizations surveyed of any sizable IT, what they will be doing by the end of 2018. So with an 80% number there, this is the future. This is where things are going to be. You're going to have to operate in this environment. Organizations are going to have to adapt to be able to deploy and operate cloud workload. And we feel it's our mission really then to help take the customers there, to take your organization there, largely with the familiar tooling that you've been able to use to be successful at this with server consolidation, private cloud, and extend that into these various different kinds of deployment fabrics. So the challenge is then, the private cloud world, public cloud world, can maintain, through that tooling, operational consistency, bring those skill sets and tools without piling on additional consoles, changes to roles, and the need to reconcile data and reporting from tools that don't necessarily speak to each other. Can you maintain, this is going to be a big part of what we'll be talking about here, the control and the management and the security. Do you have the same kind of visibility? Can you apply the same kinds of controls? Do you have to create a new set of tasks? That's probably a real impediment to do things like that. Service level agreement and compatibility with existing applications, other challenges there, things that are easy to talk about, ending up delivering them end up being the real sorts of issues towards going ahead here. So we're really looking there exactly to strike on these points. Consistency of operations, skill sets, tools, in particular, to be able to not only use the same kind of controls and protections for workload deployed in a hybrid or a public cloud, but to be able to deliver better protection and better security, more closely aligned with application and operated and managed in a way that allows for finer grained control, more awareness of threat, and tightly coupled with the underlying infrastructure itself for the kinds of protection that we talk about, like east-west protection, the data that moves between the machines inside of your environment, which is roughly about 80% of data center traffic, whether it's on private cloud or on public cloud. That's the opportunistic traffic, where the threat vectors end up propagating. It's classically like the target attack, which has become almost a cliche to talk about, avoiding the sort of general perimeter-based protections that are in place today in order to protect application and workload in the data center. And again, moving to the cloud, no matter which vendor and which particular infrastructure cloud you're talking about, doesn't in particularly solve for that problem. You end up getting generally a set of different types of perimeter controls, and you have another special rail to be able to push workload and to push management into it. The inside problem, the east-west problem, in general, is not easily solved simply by placing things in public cloud or in a hybrid situation, and in fact often is more difficult because you're running a different and separate control with generally less visibility. This is the thing that we solve for with NSX and with the service insertion for partner services, and this is the place that we've coupled, beginning with a design engagement that we did with McAfee in 2012 in order to solve this problem, and in particular bring in the kinds of controls to block threat where it is most appropriate to do so. Again, interrupt everything from the propagation of encrypting ransomware to stopping ordinary types of emerging attacks against infrastructure, things like Heartbleed and shell shock as examples. We want to bring these capabilities together so that we can run them consistently and to get the best out of both of these worlds. We want to do this in such a way, and we've introduced on VMC a way that by using the cloud foundation for the SDDC, building on vSphere, vSAN, and on NSX in particular as the place where control is defined, both for network operations and for security insertion, that we deliver this consistency and this same tooling. You will have the same NSX tooling, the same vCenter tooling, and the same partner solution in order to secure these that you had on-premise in your data center, simply expanding the envelope.
Okay, I have a question here. How many of you are looking at containers? Have the containers deployed private public cloud? You have? Okay. 2? Okay, cool.
So the hybrid use cases that we're looking to secure and some of the stuff that Amit will get into talking about what they've done also at McAfee around this are, again, the core use cases that we're talking about here. Maintain and expand, or to consolidate and migrate. And then, of course, most importantly, I think the place that is driving a lot of this economically then is the workload flexibility. If you had to protect all of these environments differently, if you had to have different teams with awareness of different tools and different scopes, I think you end up dramatically reducing the ability actually to secure those kinds of environments. The other thing is that the scales that become involved here really require a new approach. Taking traditional physical network controls, applying them, putting them in a topology or aligning them in a path for a couple of well-known communication axes is not going to be able to keep up with this. The environments are dynamic. The number of objects that end up being involved are not just dynamic, they're an order of magnitude higher. And traditional tools tend to both control and report on low-level elements, IP addresses, MAC addresses, machine names. That is not going to scale. It requires tools that are aware of higher levels of abstraction for operation and management. They'll offer better automation. At the same time, in doing so, have designed them to provide better protection, more closely aligned with the actual role of a virtual machine or an application, rather than aligned with how it happens to have had an IP address assigned to it or some other technical signifier. So the problem of securing these environments is exacerbated by using traditional tools, no matter how high quality actually the individual control is, or how good things like the malware labs research or any of the other sort of traditional security value propositions that come at the table. We just have an entirely different architecture, and laying the traditional controls against that architecture is a recipe for operational confusion, if not mission failure around this. Again, when I talk about multiple different cloud types and how we'd be deploying this, again, this isn't the opportunity to dive into how these different stacks are made, but we have a number of different deployment options ourselves, depending on the requirements of customer and their existing relationships. This is the goal that we have, that across multiple different clouds, different underlying fabric or infrastructure technology types, we will consistently be able to apply the software-defined data center properties without modification across all of them. Most importantly and critically, then again, this is the security control. The security control is the footprint by which we are able to define all of the other attributes about one of these cloud deployments and presence. VMware is able to, with NSX, to be able to establish this footprint and use this as the basis for defining what layer 2 and layer 3 networks are, stamp them out, and be able to operate from a secure default position simply by the means of how you have implemented your network connectivity across these environments. One tool set, one set of managers, one way to integrate the partner solution in order to provide full-scale protection of network data and traffic. How do we do this? What is sort of the key property or quality? What is the architectural approach that has allowed us to do this? And it's something that we discovered early on at a different phase in VMware's life, and that is the focus on the application actually as the unit of what you're trying to do in information technology, whether you're in security, whether you're in deployment and operations, because the application is the whole reason why this entire business exists. There is not a business user in the world out there who's going, we really have an interesting business issue around IP addressing. Absolutely not. They want their application. This has been then the way that we are able to implement virtual machines and why we do so. The virtual app construct became very important because what operators did is they started to deploy applications unconcerned with how many virtual machines were underneath that application when it was packaged as such. That approach lent itself very well to add additional properties to that application, including its security policies, connectivity policies, all of that. So those goals haven't changed. We want to deliver applications and data, and we want to do so focused on the application so that we're focusing on the right problem, the problem that's close to what the business is interested in having us work on. Speed of delivery is incredibly important. That's the other thing. If there's any single quality that has driven adoption and acceptance of this at the scale that it has been the ability to cut huge swaths of operations cycle and of just sheer waiting time out of deployment and operations. And then obviously application availability, because the applications are defined, how they're delivered, how they're operated, all in software. They can be copied, they can be duplicated, they can be moved, and we can play some very interesting games, starting originally with just our footprint in vMotion, and now obviously with the ability to completely ignore topology in most aspects about operating and securing this kind of workload and keeping it available. All sorts of other things have changed in the meantime. We began doing this work around security and defining it really from an application-centric idea of what connectivity is in order to define networks, but back in 2010 really. But in that time, the threat landscape has changed dramatically. It's number of hands up here that went up showing involvement with security means, again, we probably don't have to labor some of the examples, but the threat picture today, not to use a FUD, too much of a FUD angle in order to talk about this, it's pretty obvious. The consequences are high, the risks are huge, and they are regularly being realized. We end up seeing this on a weekly basis, if not near a daily basis now. Changes in the application architectures. It's not just simply placing Apache and SharePoint servers on virtualization and then leveraging the virtual properties in order to be able to better operate and manage things like that. We have all kinds of changes in applications themselves. Applications are increasingly custom, stitched together from software as a service, containerized services developed in-house, and of course, all of the various sort of emerging technologies around DevOps that are going on with containerization and microservices. This is changing really, again, for many of the other same demands that we originally virtualized. Those same pressures are pushing changes in the application architecture. So a different thought about how those are secured needs to be brought on in. And then, of course, the changes to the infrastructure itself, which is what most of what we were talking about earlier is about. So in the data center, what is the big deal here? Why is this complex? This is traditionally how it's been done. You end up having your stacks of your machines in the racks, controls placed on the rails to be able to get in and out, and in sophisticated examples or for high-value applications, you have something at the top of the rack, something aligned specifically with the location of those hosting machines in order to filter traffic. We ended up going in and virtualizing a lot of the stuff in the middle of the last decade, and interesting things happened on the raised floor. One is that desktops started to show up in there. Even if they weren't operated and run by the data center group, they were existing on the same raised floors, and with many of then the topological considerations that were going for, operating, say, the PeopleSoft database in the company. The traffic profile of arbitrary actions of a desktop user are vastly different than the usual application and workload inside of the data center. Not just east-west traffic, but in and outbound traffic, and they changed the profile of what security operations was doing in terms of what they expected traffic coming in and out of that data center, creating a lot of different kinds of noise and actually deprofiling a lot of the work that had been done for years with security tools in order to secure that data center. And this has exploded, it's expanded, both virtual desktop infrastructure and desktop applications that are hosted elsewhere inside of the data center like this. You ended up having applications that largely had to be aligned underneath the kinds of controls that define the policy, how they could operate and run, oftentimes inhibiting the value of the virtualization itself. The vMotion, the normal leveling, the operations efficiency of, and really the way that VMware has tooled this meant that these workloads of different properties and security controls were moving rapidly back and forth around, unaligned with the controls up and above them. The idea is, how do you fix this? Come on, get these things in line, move them into specialized areas, siloing again the virtualization environment. So what do we need to solve for this? What we're looking at then is the key areas that need to be addressed architecturally overall: visibility, control, and extensibility, operated all through common policy. Single policy layer, and again then lifecycle management and automation up and above that in order to steer and direct this, using orchestration tools, provisioning and operation tools in a consistent way that depend on these underlying pieces here. So the first stage, gaining visibility. This is talking about how we would deploy networks on top of NSX, where essentially you're deterministic. Your network exists because you've said, I want to do this with this application. We then had the ability to define this and add granular controls so that we're able to insert firewalling, access control as a part of the definition. You're building a network that really is conceptually like the transfer of a Visio diagram onto software, into the way that your applications connect. Your native controls become available in the platform, come into play, including the fact that when you software define something like a route, no other communication is possible. There are not other routes. When you define at 2 or layer 3 connectivity limits, that's all that there is. If you say only port 25 is necessary for this application, only port 25 exists. It's very clear, very sharp, very defined. So once we've established this footprint, this is kind of nice because I don't really consider this actually real. There are elements for a secure approach through all of this, but it isn't really InfoSec itself. This is infrastructure work. This is building clean and securable infrastructure. So when we want to talk about the security picture of this, how do we enhance this security posture? How do we leverage this foundation, this approach to building and deploying networks for security? We have the ability to attach and insert services based on the same kind of network policy definitions that we designed around the application, and we can bring controls like those that we worked with designing with McAfee into this to protect for, then again, the kind of modern threat, to analyze it, and to leverage the automation capability in this platform to be able to respond and to be able to protect with various different kinds of mitigating and compensation actions. So we're able to attach these services to the exact same policy constructs. If you have defined a microsegment for a set, say a set of mail servers, a set of web servers, there's a policy attached to those by application type. Right alongside of that, we can add the partner policy then and insert them in the exact same way that we control the network path for our own distributed firewall in NSX. So in the SDDC, what we're doing is we're putting all the intelligence in software, the sort of mapping, the idea, the exercise that we showed in those pictures ends up being realized on top of the network controller, the NSX controller. We have a common data virtualization layer. And then, again, just as you did with virtual machines, the pooled Xeon processors, the pooled disks, and the network connectivity of each of those machines, largely irrelevant to how we're going to operate this. We've got a nice green bar representing what is really the data virtualization of the software-defined data center. We don't need to understand where those machines are located, how they're configured. Their value has been entirely normalized into raw compute. That normalized value becomes the same value for most of the basic networking properties. Switching, routing, load balancing, gateways to the physical networks, including mapping to things like VLANs and MPLS. Also, firewalling, VPN, data security, and activity monitoring also become properties that you really don't need to worry about where they're located so much as to how you're defining them and how they need to be used. So we have policies, groups, tags, we have software constructs close to the business need and close to what the application does, with a pooled capacity, again, of very normalized hardware rather than very specialized hardware dedicated to particular network purpose. So NSX ends up becoming the overall wrapping frame for this. We end up revisiting visibility for the data center application. With control, we end up having this context-driven policy that is essentially defined by deploying the application itself. And then extensibility, the ability to leverage this approach in order to bring the very best controls. I'm going to go, for the sake of time, for a minute, a little quickly through this. This is really just, again, some of the showing how this actually ends up being deployed, illustration of this, how NSX gets used in order to be the footprint defining the software-defined data center and introducing a next-generation networking model where, again, the same way that we were moving our virtual machines around between hosts today, networks themselves, their properties, move from host to host, largely without regard for anything like a physical topology in order to correctly operate and to maintain consistent control. This is great because misconfiguration becomes much more difficult to end up doing as well. That you're not dependent on a number of moving parts or physical locations in order to correctly apply policy. So there's a very broad topic. I know that we've probably seen other sessions on this. What we're going to go into right now really is the extensibility. The extensibility is where the partners come in, and it's really how we end up improving not just a more securable set of networks, but offering the opportunity to have better security from the standpoint of real InfoSec. We end up being able to introduce directly into network packet flow partner solutions to be able to gain visibility, to identify, and then of course to make the security decisions protecting networks. And we're able to do so in the virtual network before you've ever even talked to the virtual switch. In the same way that the NSX distributed firewall is attached to the virtual machine, not to any other larger virtual network construct. Although there are virtual switches present, the firewall is implemented at the virtual machine relating to the application. We offer the same communication path then for the partners to attach right behind the distributed firewall and process network communication for that virtual machine in a secure manner before that traffic has either left the virtual machine into the broader virtual environment or before it has arrived at its destination there. So we're really bypassing many of the control points that exist in the physical network, not to make things more obscure, but to get the control exactly where it's needed so that you have some of the intelligence and context and awareness that agent-based software would have with the ability to operate on that wire like the best of the network solutions. One of the things then, again, also is we have the ability to use tagging for policies so that we can create automation actions that coordinate what we'd be doing with the distributed firewall and something like both specialized isolations and quarantines, but also then taking actions based on those things. And if we're going to take an action based on a policy because of a condition that changes in a tag, that is also the same exact coordinated response that will happen on the network and in controls with the partner control, with McAfee solution as well. Policy is by default coordinated, including all the possible workflows and actions out of them. And we get this without having to do lots of other horizontal integrations. If you have a next generation firewall from one vendor, an anti-malware from a second vendor, and you have intrusion prevention and detection from a third vendor, they will operate in not just in aligned policy, but also in the activity and automation without any of those three solutions having had to explicitly try and talk a common policy language. They behave as if they do. This is really powerful. This is some of the great strength of what we're able to do in security on NSX and for the software-defined data center. And again, extends, because we've moved away from the physical topology to the hybrid cloud, to the public cloud deployments, because they no longer really care on what physical network or which underlying device they've been configured to operate this way. So with that, I'm going to move on over to let Amit talk about the McAfee protection and controls, but with the point again, driving home again that what we're able to do is we're able, because of our unique position in software underneath the application, defining how the application connects, we're able to get then both the context very close to that application while providing the kind of isolation that you're able to get by being located on the network. Really in the best of both worlds, the origin of what we were calling the Goldilocks zone for the past couple of years. And key to that is that we're ubiquitous. We are the common layer. If you are deployed on the software-defined data center, the controls by default exist at all times. You can't escape them, and they operate outside of an attack footprint of the workload itself. So they can't be turned off by anybody with an application or a server management role. With that, Amit?
Thank you, Jeremiah. So I think this is really powerful, right? Isolation for your application, how you can actually arrange security at runtime. So critical application, they got compromised, you can isolate that. There's really powerful stuff that VMware has done. And let's just face it, VMware has been a real game changer. This was your typical data center, and you've explored into cloud. And you talk about AWS or Azure, you talk about serverless computing, Docker, it's just been exploding. And as you have moved your application to the cloud, let me ask you, how did security matter? How's security been so far? So we started things like hacking and breaching was just not a child's play anymore. It's just not somebody trying to get credit card numbers and showing up to their friends. This has become a serious issue. This is now has the capability of launching wars. There's a cyber warfare that's going on, but it has started impacting the entire population in very profound ways. Between all these breaches, I can tell you almost all of us have our personal identity compromised. Not to alarm you, but that's just the fact of phase of life you're living. And what McAfee is doing is this journey as you move from your private data center into the cloud, we don't want these things to happen. And one of the important things Jeremiah pointed out that your security controls don't have to change. How you deploy that, your architecture, processes, best practices, they need to be aligned. So let me walk you through some of the work that McAfee has done in the data center, and as we go into cloud, how are we securing this application? But before I do that, let me set the context. This is a traditional how it's working today. It takes literally minutes for a breach to happen, actually. With the vulnerabilities, if you're familiar with Pataya, which was the vulnerabilities that was exposed to those CIA tools, it took minutes to access any computer, put a ransomware, encrypt it. However, it takes years and months before you can actually detect a breach. I'll give an example. If you're familiar with the Sony breach that happened a couple of years back, that breach was sitting on Sony's environment for about 2 years before they could discover that. By the time they were exfilling data. So your typical tools that looks for anomalous network behavior, those compromise that, they actually were sending legit data packets over a legit network, very small amounts of data. But as an organization, I think the most challenged part is the last part of it, is time to recover from a breach. So there are two things that we talk in the security business. Either an organization has been breached, or organization has been breached but doesn't know about it. But once you know about it, how do you actually recover and minimize that recovery period even if you have breached? So our goal over here is to minimize the attack surfaces so your breaches take longer time. So as you see, the time to compromise, we want to create more barriers for the bad guys to get inside. And we want your discovery to be right away. One of the reasons that discovery takes a long time is because the security team in your organization is typically preoccupied with a lot of regular tasks. It is provisioning security controls on application, looking at alerts. And whether it's McAfee or any vendor, every security application generates a ton of alert. How do you actually go through all of that? So one of the goals over here is to minimize that time to discover, is look at your alerts and actually filter in and zone in things that really matter. And finally, you want to make sure your impact is minimized so you can recover really fast. So setting that context, this is kind of the paradigm that McAfee is working on as we save application. I want to actually go through a little faster because I have a very cool demo I really want to show, especially going to AWS and how we actually mitigating some of that. So one of the things that we are looking at is security as we get involved with VMware and a lot of these deals that we go in, and security has become a very central part of every project. It's literally become a CIO, C-level discussion. And the first thing that matters is visibility. So one of the challenges when we talk to the network infrastructure team or the data center team is that we have this shadow IT that has been spinning up VMs, which was fine when you were inside your data center, but when you go to cloud, you almost have no controls. How do we at least find out what's running? unless I see it, I cannot really manage it. So one of the things you're going to go is have visibility, which is the first part. Then some of the attacks, as I mentioned, Petaya, some of the zero-day attacks, how do you actually can mitigate around that? So we want to get you that tools to make your breaches discovery that much faster. And finally, we want to automate all of that. And my demo is actually around automation. Security cannot be bolted in any longer. So NSX gives you that platform to provide at real-time security controls. And we actually leverage, as a third-party vendor, you can include those services. We natively integrate with VMware NSX in the platform. So before I move forward, is security like a big part of the discussion when you talk about projects? Yes and no? Yes? Anybody? Great. All right, so one of the things we talk about security is, first of all, is visibility, before when I put the controls in, right? So one of the challenges, as I mentioned, you have the vCenter to look at your workloads that you're running. But what if you're running off premises? What if there are these rogue applications that I get in from? So I used to work in, I would go to my system administrator and say, hey, let's go out for lunch, and we became buddies. Hey, can you spin out a WordPress for me? I want to just have some documentation. I want my team to kind of use that as the portal. And he would do that for me. There was no security in there. And I'm sure there are a ton of those running around every organization. How do you manage this visibility? So we want to make that happen between the physical and the virtual world. That's the goal over here. Then back to visibility again. As you move into the public cloud, you do not have access to the infrastructure. You do not have access to the hypervisor. Everything's virtualized. The networks are virtualized. Your workloads are virtualized. How do you, again, get the visibility in there? And back to shadow IT. This is the data we actually got from our feedback from customers. 82% of organization have no idea what's that scope of the SharePoints and the WordPresses that are running and that don't have any security control. The whole shadow IT. The marketing department wants to run a campaign, right? My organization, I had a previous organization to work, startup, they went and took out their credit card, got a third-party agency, and the agency was running an application on Amazon Web Services, and boom, it ran. Part of the campaign was collecting private information from the customers. That's a PII violation. If you're in a compliance part of the market that your organization is, you might be held accountable for that. So how do you manage the whole shadow IT? So one of the things we do is a tool that we call Cloud Workload Discovery, which actually will go through your accounts, whether you're running VMware, Azure, or Amazon Web Services, and actually look at all the VMs that are running, all the compute, all the network, and kind of create the security posture for you. It's like a report that you can get right off the one single screen. Things like unprotected endpoints. We can look at memory protection, some of the tools in here. So this also discovers networking and storage, which again, in a cloud environment, you do not directly have access to those environments, right? So you pick up those information right from the metadata that the cloud provider usually gives us. And if you're running a multi-cloud, which I think every organization is, how do you get the visibility again back to? So here's the tool. If you look at it, left-hand side, we have the accounts from vCenters. If you're running vCenters inside your premise, if you're running an Azure workload, if you're running an Amazon, it'll show up on single place. You can look at the workloads that are running, the networks that are there. And not only that, on the right corner, you see all the security controls. How many of them have been compromised? How many of them have actually security controls? Have you put on antivirus? Have you put on IPS? If you have a security control policies, you can actually import in there, and it'll show you violation of your policies. Some of them come out of the box right from the application itself. If you're familiar with McAfee e-policy orchestrators, we call it EPO. Now, that is now works across entire virtualization stack as well as the cloud stack. So we support Amazon, Azure, VMware, OpenStack. And below that, any of those construct of a data center, compute, storage, and network will be able to protect that. OpenStacks, anyone doing work around OpenStack with VMware NSX? Nope. So next one is database security. As you go and deploy your applications inside your both your private and public cloud, we have a database security solution that will actually look at your database and look at any kind of integrity violation of your database. Now it works both your, again, as I said, private and public cloud. It first discovers and creates a benchline, again, does an assessment based on that, and then gives you the security features. Then you can apply policy based on that benchmark. Next one is that Jeremiah was mentioning our integration with VMware NSX. So I'm pretty sure you're all familiar with McAfee, and what we do in McAfee is one of the biggest product portfolios, our antivirus endpoint. But I'm not sure if anyone is familiar, we actually have a great IPS solution, which is an intrusion prevention solution for your network security. So we have integrated our product IPS. So what we've done, we actually one of the leading vendor in the market today. We have taken our product IPS and virtualized that and build that on NSX using the NSX third-party integration services built on that. So the way it works is if you have ESX host, you put a VM on each one of the, let me build this out. So each of the ESX hosts will have what we call a security virtual machine or a service virtual machine. And NSX has policies to shape traffic. So whenever packet flows from one VM to another VM, we can do introspection. That's the, Jeremiah was talking about the network introspection of your packet. And based on our IPS solution, we can look at those packet information to see what are the threats in there.
What I think is really interesting about this then too is we've taken this best control, one of the industry best controls about IPS, and taken the problem with it today in the modern deployments and in the software-defined data center and in the hybrid cloud, because it's no longer simply a perimeter-focused filter, mostly on inbound traffic, which was not where the threat was entering, not where the threat was propagating. We've now been able to distribute that engine and that intelligence for filtering into the fabric of the network and apply it as a service at needed, very close to where it has to be protected, bringing it back not just into relevance, but actually making it in many ways a better control than when it was simply a large inbound network filter. The inbound network filter still has its role, but you now have been able to take this and apply this directly to the kinds of threats and visibility that Amit was talking about in the threat perspective.
That's a fantastic point. So part of the packet processing, if there are files attached in the packet, we can carve out files, right? We can look at the files and look at the malware inside the file too. And if you have policies to block it, we can block it. And if you're worried about blocking traffic, we also operate on detection mode. So we can only monitor it. And if you have another alert system, we can give you critical alerts based on that. But again, back to Jeremiah's point, this is really critical because you're no more endpoint-centric security, which means you're not based on operating systems anymore. You could run a Linux, Windows. Since we are looking at network introspection, we are not constrained by the operating system, agents and stuff like that. So if you have a core OS, if you're running Dockers on them, yeah, you can run a network introspection. We can check right over there, everything on the wire. And NSX gives you the capability of really giving that high speed because we work at the hypervisor level. So we go to the VMCI channel. It gives you the throughput. You almost see almost no latencies. What we do is we tag the VMs when we see a VM that has been compromised. One of the Jeremiah was pointing out, when you do critical application, how the isolation and the policies can help you. So we can tag it, and you can use NSX policies of quarantining it or putting it in a place that you want to explode your VMs and look at it more as a postmortem. So again, this builds on VMware's NSX architecture and natively integrates with them. We are a VMware NSX certified partner. So when you actually buy this product, this solution is guaranteed as a partner solution from VMware as well as McAfee. So we are here, both of here, to solve a problem, just not one. This is kind of the visual aspect, how it looks, as I was mentioning, each of them. So this is the management platform, the two pieces to the management platform. or the IPS works over there. But each ESX has its own IPS, so it kind of controls its own environment on those ESX hosts. Now, one of the cool things about NSX is as you spin up the ESX host, those service VM, the security VMs, the virtual IPS, automatically gets provisioned. So you don't have to worry about manually provisioning those IPS. You move your VMs, your policies, your IPS policies will move with those VM. We actually support the vMotion capability inside, as long as in the part of the data center. If you're using the multi-vCenter NSX controller, that's integrated too, by the way. If you're using OpenStack with a VMware version of OpenStack, if you're using Neutron with NSX, again, the virtual IPS will work with that. So that is what the level of integration helps. So you're future-proofing some of your investment by getting into McAfee solution with VM NSX.
And you're really still using one console and one set of tools that you have also already been using for your physical environment.
Exactly.
With sort of transparent addition of these different new deployment scopes.
Right. This is just a platform support. If you're interested, obviously we have more details in the data sheet, but just to give an idea, the flavor that we do. We have another endpoint solution, which is our antivirus solution. This is an agentless antivirus solution. Again, it has its own service virtual machine. It goes in every ESX host. It looks at files. Again, it's an agentless solution. We depend on the VMware tools to deliver us a file hash, and we can scan files for viruses in the file. This is called MOVE, McAfee Optimized for Virtual Environment, stands for. It uses the EPA console, which has become the ubiquitous management for all endpoints. A lot of our customers use EPO even to manage change control, patch management, any kind of things you can do with System Center, Microsoft System Center. Again, we support multi-hypervisor. So if you were to use any other hypervisors, not naming them, we do have that support. Managed through VMware NSX integration, same thing. We can tag a VM. We can quarantine the VM at runtime. If you see a malware, if you want to delete the VM at runtime, a lot of customers do that. A high level of automation, you can do that. Switching gears, as Jeremiah kind of led off the journey, and as I started off, is that cloud has been a journey for a lot of our customers. You move those VMs. How does the security move? So this is a simplified representation of AWS deployment. I don't know if you're familiar with it. I'll show you actually a cool demo going through the AWS console. But if you think about it, I don't know if I get the red thing. So these are the red boxes is where the virtualized IPS sensor is. These are virtual machines, the yellow boxes, that has got McAfee agents in them. We call them virtual probes. They're network probes. They sit on each EC2 instance or a virtual instance. We can work this again on Azure, same architecture. On the left-hand side is our management platform. So Network Security Manager is where your policies are. The controller, it creates an overlay network. So this is sitting inside a VPC. So example, if your network packet flows through, this is an Amazon load balancer. It looks for a virtual machine where it can direct traffic. As soon as it hits the VM, it redirects packet into the virtual sensor. And the reason we do it is that we don't have access to the hypervisor. The cloud providers manage your hardware and everything in the hardware infrastructure, your network, your storage, your data, your compute. All you deal is with the virtual environment. And this is one of the ways where we are able to actually capture traffic data, layer 2 to layer 7. We encapsulate that in layer 3, by the way, but we capture all the data across. And the data packet gets inspected on the IPS sensor and goes back into the, depending on the policies that you have set, we can either block the packet. If the verdict date is exonerated, we'll let the packet flow through. This entire architecture, I have a demo which can be deployed in less than 20 minutes. That's the other aspect of security we have started seeing in cloud is high level of automation. I'm going to flip through really fast. This has got an automatic load balancer, so if your traffic spikes up, we can actually horizontally scale a sensor. Again, as your traffic spikes down, we can again scale it down. So it is a very elastic more of IPS sensor. You can make it work with your existing VMware infrastructure, use the same policies, If you have a virtual IPS or a hardware IPS that's sitting with your firewall, you just use one security manager. That's our management control is the network security manager, the green box. You can go across both the environment, either through a VPN, using Direct Connect, any of those environments. I'll be happy to discuss more details after this. I just have a few minutes left. I do want to show this demo here, but happy to discuss. This is, like, as I said, a very oversimplified version of our deployment and how we do it. So the next phase, again, I'll be deploying the whole infrastructure. There are a lot of things going here, by the way. Those EC2 instances, the VPC gets created, the virtual network that's created, there's a security group of Amazon that gets created, and the firewall policies. So here's one of the details on that. So this is your typical AWS console. As you go into the console, I'm logging in. This is my login, my access on AWS. This is your typical AWS management console. Just show you all the EC2 instances that are running in there. Well, then I just go into the CloudFormation template. So this is an automation tool, a JSON-based automation tool that Amazon uses. And I can just give you the URL of my template. And here shows the topography of the deployment, what I'm going to deploy. So as I was mentioning, all the EC2 instances, there's a VPC that's getting created, virtual networks that are getting created. There's a load balancer that actually we drop in there too. And this is the power of software-defined controls. And what you're trying to do is making sure the security also coexists when you have that level of automation. So going back, I'm going to launch that again one more time. Pass on the URL. And it comes up with some predefined values. If you see the service VPC, all these IP addresses are the CIDR rules you can change based on your topology and your environment. We do require the AWS access key for a read-only permission. And the IAM policies of AWS lets you decide how much of control you want to give. So I'm exchanging the keys over here, naming a cluster. So the sensor gets deployed in a cluster mode, the IPS sensor. So you have a heartbeat. One fails, you can still use the other one. It does need the key, so I'm going to bring up some of the virtual machine. Security is built into these cloud platforms, much like NSX, where before you actually deploy the VM, you deploy the NSX. So all things this does is it integrates with the auto-scale feature of Amazon as well as Azure, which has thresholds. You can say 70% of compute, 50% of memory, based on which you can spin up VMs as your threshold goes down. That's it. I go through two steps, hit the create control, and it starts deploying. And you see, started deploying right away. And here's all the objects that are getting deployed. These are all Amazon objects here, but you have to see the VPC got deployed, the internet gateway. So the entire stack gets deployed. On top of that, we deploy the IPS control. So things like SQL injection, cross-site scripting, typical web application, that's built into the tool.
What I think is great about this then too is that you've extended the policy schema that was established for the NSX deployment with like the service composer microsegmentation, defining those applications. They're now applied with policy consistency to objects that end up being instantiated on Amazon or AWS, so that the people protecting this are looking at what is to them still the same protection scope and the same protection policy without having to be experts in the underlying differences about how infrastructure ends up being deployed and operated.
Right. Yep, so that was the thing we just concluded. We do have a test drive version available, so if you want to test our product, we go on McAfee, look at IPS test drive. You can just drive that, and exactly what I just deployed to the automation tool, you can feel free to run with that. Thank you for your participation, and I'm happy to take any questions. So is Jeremiah here?
I know it's interesting that you're getting here
Yes,
this early
please.
in the meeting, so thanks so much also for being able to come in early. You know, I know it's a little difficult on third day of a conference.
So I was going to say, is everybody starts to move towards microsegmentation, the hypervisor will become a bigger and bigger target. So, who protects the protectors? In the sense of, within my own data center, if it's fine, I control the hypervisor and I can throw connections there. When I move into Amazon, now I'm relying on Amazon to protect the hypervisor. If somebody's compromised their hypervisor, they can set up another VNA to potentially bypass that. Yes.
So, go ahead.
It's interesting because, about 5 and 7 years ago, there was a lot of interest in being able to attack the hypervisor itself. A bunch of research went into that. You saw stuff coming out of Black Hat. What I find interesting now is that, in general, the hypervisor this is the way information security works. The hypervisor is well enough protected and enough other things have enough problems with configuration and inherent vulnerability issues that the ease of attack, although it looks like the hypervisor itself is sort of the rich place to go, if you can compromise at the level of the hypervisor and get an escape, you have all of the workloads. The payoff is potentially very big. However, the work is generally very hard. It's basement tunneling kind of attack work. And the applications themselves and the frameworks for the applications, the languages they're in, how they're deployed and configured, tend to be, it's like the upstairs windows are still open. Attacks move to the area of least resistance. That said, I don't believe it's something that we can overall ignore. If we're bringing this level of protection into general network traffic, if it is a click operation to be able to protect these applications from those kinds of attacks because you're aware of them on the wire, we will be putting pressure to move things elsewhere. So I do agree that it's something that needs to be looked at and tracked, but the actual history and incidence of these sorts of attacks are pretty low, and they generally end up requiring an administrator level, root level compromise on the platform itself to work. And so far, from what I've seen of most of them, it's a theory, it's a gaming exercise, because once you have root level access on the hypervisor, you don't need to break into it to do something with all of the workloads. But I agree, that is the thing, it's that one-to-many that makes the hypervisor an attractive target. Certainly, that won't go away.
So I actually have those questions from customers, and when I talk to customers about security gaming, and they say exactly that Amazon or Microsoft has been telling us they provide security, you don't have to worry about the applications that are running there, which is true, but not fully true. Comes to your point, how do you protect the hypervisor? The responsibility lies on those cloud providers to not only the hypervisor, but the firewall that is getting in through that network. They are ultimately running in bare metal, right? They're supposed to do that. But I just showed you, the security is the last mile. So your endpoint security is still securing an endpoint. We are very confident we can secure even if your hypervisor gets attacked. So one of the things about all these cloud platforms is they're multi-tenant. So they are, you're using you're sharing your space with somebody else. So this is what we call the last mile defense, and we're pretty confident of actually ensuring some level of security, and at least letting you know what's going on. We have the visibility with that solution we just kind of showed you. Thanks for the question. Yeah.
Okay, great. Thank you,
Thank you.
everybody, very much.